Okay, so today I'll be going over funcX Executor, which essentially allows us to run Parsl tasks natively within Globus compute endpoints. So for the rest of the presentation, I'll be referring to this as funcX Executor, but it's pretty much a Globus compute executor that's natively within Parsl. So in regards to the funcX Executor, our primary goal was to allow users to execute the Parsl workflows and Parsl apps on funcX endpoints. And this essentially, in my opinion, provides the necessary infrastructure for Parsl apps to be run on separate endpoints. And in my opinion, this allows us to have mobile high-performance parallel computing. And in regards to some of the methodologies that we've explored so far is we've currently created the funcX executor natively within Parsl that allows us to connect to a singular endpoint. And this enables us to run those Parsl workflows on a funcX endpoint. And we've leveraged the PyTest suite within Parsl to make sure that the behavior is consistent with local threads to just make sure that the results we're receiving are consistent with what we expect. And in regards to my research efforts, I primarily consulted with Ben Clifford in regards to my ideas and my methodologies. And in regards to why I want to include a funcX executor natively within Parsl, I think it just allows us to be more scalable. So the ability to run your tasks on multiple systems and multiple endpoints rather than purely local threads. And this in turn also leads to higher performance. It also allows us to have a more fault tolerant and load balancing system in case any of those endpoints or systems does fail. We still have other endpoints executing those tasks, which allows our parallel workflow to continue to execute if any endpoint does fail. And this just allows us to have a more cost-effective system as a whole. This allows anyone to have that large compute resource without having access to a singular HPC. And overall, again, this allows us to have that mobile high-performance parallelized computing. And in regards to the current working implementation, so we currently allow users to execute Parsl apps on a singular funcX endpoint, like I stated before. And the behavior is mostly consistent with what you see on local threads, as it allows us to run them parallelly based off the amount of workers or threads pre-initialized within that Globus compute endpoint. However, we did have some unexpected behavior in regards to the type error of return types within these 3 specific test cases that we're continuing to explore. So if anyone does have feedback after this discussion, we can discuss that for sure. And in regards to the current implementation, we do have a funcX config file within the Parsl test directory and Parsl that allows us to call our funcX executor natively that lets us run these tasks on a funcX endpoint. However, this is not the end goal because our pure idea is to parallelize alongside multiple endpoints and not a singular funcX endpoint. However, we do have some results from this current implementation that I think are still necessary to discuss. So we do have that singular endpoint execution system that does not leverage that multi-endpoint parallelization. And based on our current system as well, our parallelization is quite limited to the number of workers initialized within the creation of that endpoint, which we do not want to have at the end. However, there are some benefits and takeaways. We know that we can execute these Parsl apps on a funcX endpoint, and we're able to leverage some utilities like Parsl Visualize and something I worked on last summer called funcX Visualize to compare these workflows and try to understand the relationships between Parsl and funcX, and just gave me more development experience as a whole with Globus Compute, Parsl, and general development practices. And now for the more interesting stuff, the multiple endpoint implementations. So the main thing that we have to consider here are pending tasks when there is no endpoint available. So based off, we need to make sure the tasks are still organized in some dependency structure. And this is taken care of based off the Parsl data flow kernel and the executor implementation we currently have. However, if we do want to take a different implementation here, we still have to make sure that we store the tasks in that topological structure. And the main component here that I want to focus on today is that receiving and interpreting results. So based off the existing funcX or Globus Compute executor, when you are running these tasks and you receive that temporary endpoint, temporary output, this is stored within the queue within the funcX executor. However, since we're running it on multiple funcX endpoints, we have to host some sort of globalized queue within the executor itself, within the funcX executor within Parsl that's able to route to the other more specialized Globus Compute executors that are connected to singular endpoints. And I think this part is specifically important as we can have that data input up to date. And in regards to the endpoint scheduling system, I want to make sure that we have separate sets of available and all endpoints so that the queries are constant to see the endpoint status. However, we'll also have that set of available endpoints that we can direct tasks towards. And in regards to some of the continued requirements in design, we want to make sure that the parallelization is modular. So based off the way the Globus compute endpoint is initialized, the number of threads / workers per endpoint is pre-initialized along with the number of cores. Thus, we don't have as much flexibility as we do with the current implementation of Parsl with our local threads. So that's the reason I think it's important for us to have some sort of task categorization model that allows us to either pair the amount of cores or that we may seem to need for a specific task for peak performance. And this allows us to submit threads closest to that core requirement. And I also believe it's important for us to have that race conditioning handling because we are dealing with multiple endpoints and multiple systems. So when we're updating that globalized queue, we have to leverage a multi-processing queue. So we have access to that output, but it's still in the computationally right chronological order when we're utilizing it. And most importantly, I think it's important for us to have a well-thought-out user interaction system, specifically in the way that we have that user-provided list of registered endpoints. We don't want the users directly to edit the file, include their endpoints within the configuration. We want it to be in some way that they submit their auth with the endpoints so that we can directly implement it. And in regards to another discussion point that I would want to discuss later is how we want to establish that pair with tasks and their core requirement, or just like the amount of requirement we think for compute. And some of the past roadblocks I had was version control with the uniform Python version and conda environment. And another issue I had was the connection issues with AMPQS connections and SSL certifications. And we initially thought this was due to the university's firewall. However, we realized that it's due to the VS Code terminal having some inherent blockages. So eventually when we did switch over to the vanilla terminal, everything was more flushed out. And the existing Globus compute tools are very important for us to use as well, like the service self-diagnostic. And in regards to some of the upcoming and future work, we want to continue to flush out the executor pool. We want to create that system where we're ensuring the optimal thread is used. And yeah, I can share this presentation alongside any other information within the Parsl chat. And I wanted to also discuss a project I worked on last summer called funcX Visualize, which essentially allows us to create visualization with tables regarding usage trends for specific users and the global funcX community. So please reach out if you think there's any specific visualizations or data tables you think would be important to include so I can continue to update that service. Yeah, I just wanted to thank the entire community and I'm really glad to be here. Thank you.